Let's go over number 18 of the release questions by the SOA for exam P. So right off the bat, really sorry about the haggard quality of the question, but this is just simply the best quality I could find. But I'll read it out loud and hopefully it'll be easy to understand. So let's give it a go. So two instruments are used to measure the height h of a tower. The error made by the less accurate instrument is normally distributed with mean 0 and standard deviation of 0.0056h. The error made by the more accurate instrument is normally distributed with mean 0 and standard deviation of 0.0044h. Assuming the two measurements are independent random variables, what is the probability that their average value is within 0.05h of the height of the tower? So we have two variables, and we're going to denote them as x1 and x2, just make it easy. So x1, and that's going to have mu1 is equal to 0, and standard deviation 1 equal to 0.0056h. Okay, and then we're going to have x2 also, and that's going to be mu2 is equal to 0. Standard deviation 2 is equal to 0.0044h. So what do we do with independent variables and we're combining them? So basically, for expected values, we just simply add them up or do whatever we need to do in order to get them into whatever we need to transform them into. So in this case, we need to transform them into an average value. So x1, we are going to find the average value of x1 and x2. So we're going to make a new variable called y, right? Y is equal to the average value of x1, x2, and that's going to be our y function. So the expected value of y is going to equal to the expected value of x1 plus x2 over 2. So see, we just substitute x1 plus x2 divided by 2 into y there, which is also going to be equal to 1 over 2 times the expected value of x1, put a parentheses over that, plus x2. Sorry about that, I'm running out of room here. And then, see, another parentheses around that. That is going to equal to 0, right? Because the mu1 and mu2, they're both 0. So the average value of 0 plus 0 is going to be 0, right? Now, what about variances? So the variance, transforming a standard deviation into a variance, you basically square the standard deviation and that turns to a variance. But now what we need to do is find, we're given the standard deviations of x1 and x2, but we want to find the standard deviation of y, right? The fastest way to do it, or the easiest way to do it, is first find the variance of y, which is what we're going to do. So I'm going to start down here, right? The variance of y is equal to the variance of x1 plus x2 divided by 2. And then we pull out the 1 over 2 out of this equation, outside of the variance parentheses. And what that does is square this part, and then times the variance of x1 plus x2. And then the next part of this formula, it's going to be 1 over 4 times the square of the standard deviations of 1 and standard deviations of 2. Right, so we're going to do this of 0.0056h squared plus 0.0044h squared. And then that should equal to, let me pull out my calculator for this, 0.0056 squared plus 0.0044 squared divided by 4 is equal to 0.0001268h squared. Okay, now what is the standard deviation of that? It's going to be, so the standard deviation of y is simply going to be the square root of this variance of y, which is equal to 0.00356h. So now we have our standard deviation and our mu, and now we're ready to actually solve the question. Okay, so I rearranged some things just to make it easier to start working on the next part of the problem. So don't fear, I put our answers for the mu and the standard deviation right at the top, so it's easy to see. But let's keep going, shall we? So now we want to find whether the average value is within 0.005h of a range. So this basically means we're going to find the probability of it being between negative 0.005h to y to 0.005h. So the first part of this is that we're going to look for a normal distribution. When you look at the z table, it's going to be cumulative, and they're probably going to give you only the positive values. So we're going to first look at this part, the 0.005h. So let's do that. So it's going to be the z formula is basically going to be you go 0.005h minus mu, right? That's your expected value of y up there. And then you're dividing by the standard deviation of y, so 0.00356h. Let's call this z1, right? Okay. So what is this? This is going to be 0.00356 0.005 divided by 0.00356, and that Z1 is going to equal, we're going to round to 2 decimal places, 1.40. Okay, and let's do it for Z2 as well. Since we have this formula down, it's going to be negative 0.005H minus 0 divided by 0.0035, whoops, that was a 6, 356H. And that's the same thing, just a negative sign, so it's going to be negative 1.4. And now, if we look at the Z table, so let me pull up a Z table and then start looking at it. 1.4 on the Z table is going to be, for 1.4, it's going to be 0. Let's see, probability of Z1, it's going to be, whoops, 0.9192, and for probability of Z2, it's going to be 1 minus 0.9192, which is equal to 0.9192, 0.0808. I think it would be better to denote these as cumulative functions, so we're just going to call these f of these to denote that these are cumulative functions instead of probability density functions. So don't think of these as PDFs, think of these as CDFs. Okay, so in order to get in between what is between 0.005H and negative 0.005H, you have to remember how a normal distribution looks like. So the way it looks like is this. And when we're looking for Z1, right, we're just going to call this dotted line Z1 here. The shaded area is going to be everything within that CDF of Z1. So that's going to be 0.912, right? So that's going to be most of the probability that is going to find itself within Z1, the area of Z1. So anything below that, that's within the realm of the probability of 0.912. So because we have Z2, Z2 is probably somewhere around here, right? So what we need to do is subtract the CDF of Z1 minus the CDF of Z2, which is going to be 0.912 minus 0.0808. Whoops. 808, and then that's going to equal 9192 minus 0.0808. Okay, 0.8384, which is going to be our answer D, and that should be the way you solve this problem. This is kind of like a longer way to solve it, but I personally like to use the longer way to solve things just to be a little bit more sure about my answer. But there are definitely shortcuts to solve this problem, but just my personal feeling about how to solve this, I think I went the longer route when I took this exam. So hope this helps, and if you like this content, make sure to leave a like on the video. Thanks.